Camille holds an associate research professorship at CNRS in computer science. But as a matter of fact, Camille has also held tenured positions in sociology, first as assistant professor in Toulouse and then as associate professor in Sciences Po for 2 short periods. His research precisely lies at the intersection in between social and computational sciences, and his research interests range from the modeling of sociosemantic network, sociosemantic systems, social cognition, algorithms, and mathematical sociology. He's now leading the computational social science team at Centre Marc Bloch in Berlin on Friedrichstraße, and is also the recipient of the SOCSEM ERC grant on the fragmentation in online public space. So today, Camille will tell us about algorithmic recommendations using a series of empirical online cases is going to use as an illustration. So you know the rule of the game, Camille. You have 40 minutes for the talk. And for everyone in the public, please use the Q&A box to ask your question. And I read the questions a lot for Camille at the end of the talk. Please, Camille, the floor is yours.
Thank you very much, Jean-Philippe, for this introduction. And I'm happy to be here and invited for this seminar. I would like to take this opportunity to provide an overview, also an empirical overview on the questions related to the design, the effect, and also the use of algorithmic recommendation. So perhaps a little bit of framing first. I typically like to introduce 2 issues and thus a double dichotomy for the framing of the impact of such a recommendation. And the first issue relates to the gap between the intentions, the actions of users when they are using algorithms versus when they are not. It's also an issue that's often framed in relation with terms such as fairness, neutrality, justice, impartiality, among others, many other terms, and basically questioning how to guarantee some equal, balanced, unbiased access to such and such, let's say, stuff. It also pushes the question further without necessarily providing the means to solve it immediately. So, I mean, it keeps the normative debate open. And there is a more descriptive approach typically found in computational social science endeavors, which is meant at framing this in terms of estimating the distortion with respect to some baseline, and typically an organic one, that is when users behave autonomously, if it's possible to describe that. And the question is then, how does such or such algorithm shift users away from some reference? And the practical thing is that it does not necessarily mean to reverse engineer the algorithms to understand their functioning in very precise terms, or even to have to define some notion of bubble, for instance, and show that they produce or do not produce it. And so typically this discrepancy can be framed as a continuum between a very small discrepancy, let's say where algorithms read our minds, versus a higher discrepancy in terms of these actions where they are likely to change our minds or our tastes. Let me give a very simple and trivial example from several years ago. I started with search engines and the possibility that the autocompletion has a diversion effect on users. For instance, it was framed this way: when users start to type something, some sentence that may be related to some prejudice, the suggestions that are aggregated on the searches of all users may be displayed to users, and in turn distract them and make them look for something else. So that was the question. For instance, let's say you're looking for information on Donald Duck. You start to type Donald, and then you have a lot of suggestions at this time and age, mostly related to Donald Trump. So the question is, do you look for something else? And so the empirical research on this showed that there is no real impact on actual queries, that the visited web pages or even the transition from a query to another query was not modified by this autocompletion, that most users rely on autocompletion halfway or for rare terms. So in this case, the user would keep typing Donald Duck, having this suggestion. And so this device, this algorithmic device, could rather be framed as a cognitive helper. It helps the productivity of search, and reads our mind indeed. Another example of this framing of the shift is related also to the relationship between filter bubbles, possible filter bubbles, and echo chambers. There's an old series of results now that are showing that, for instance, the structure of online social networks is fragmented, organized in social semantic clusters. Typically, if you look at political labels, political colors in the US context with the blue and red typical labels, you'd find organically, if you look at blog networks, for instance, with this result of 2004, such a fragmentation, so such a echo chamber phenomenon that has been replicated several times. So that's the organic baseline in a way. And so the question is, to what extent, if you add some algorithmic devices on this, there is a change with respect to this baseline. And so we can take, for instance, this example of this paper that's already 6 years old, using Facebook data. That's, I'm not going to debate the results, but I think the framing itself is interesting here because it shows that based on the social surrounding of a user in terms of their friends and Facebook, which we know are essentially coming from the offline world, these networks, these organic networks are already homophilic, segregated in a way, and consistent in terms of colors. So there is a potential from that network that is the responsibility of the user in a way. Then the algorithmic device, let's say the news feed, kicks in. And so there is a selection of the content users will be exposed to. And then the user comes back in terms of decisions by selecting some content. So there are 3 stages. 2 of them are decided by the user. And the question here is to what extent each stage changes the actual likelihood of accessing, for instance, cross-cutting content. And so these kind of approaches illustrate very much these attempts at appraising the shift with respect to the organic reference that is there otherwise. Another dichotomy, a second issue, is to understand these algorithmic recommendation devices as part of an ecosystem, which is typically found on platforms, and where there are 2 important steps. There is a sort of, let's say, back office computation on the information, whatever the information, so rearranging it to propose a ranking that's adapted, tailored to user needs. And then there's the downstream arrangement of information. That means how to display this information, what to display from this information. So in a sense, recommendation is the compound of this, let's say, pre-processing phase and post-processing display of information. So it's sort of 2-step algorithmic flow of information at the level of the user. First, this information projection or reduction is typically addressed by information processing fields, so mostly related to computer science. And the second one, information display or restitution, is rather the concern of scholars in psychology or human-computer interaction fields. In any case, you have this continuum between the upstream and downstream stuff. So the whole question is to disentangle all this. For instance, let me give an example about the arrangement of information. With this old study now, 2006, with artificial song markets. So people can download songs on the platform, it's an artificial platform. And at any point in time, it's possible to compute the number of downloads that have been associated with a song. And so the ranking of these downloads influences the ranking of the presentation of the information. It's pretty much like the devices you have, for instance, a newspaper, online newspapers, where you have the most shared articles. And so the display is made according to a trivial algorithm, which basically just computes the number of things that have been read, shared, etc. What they found in the 2006 paper is that when you display the information about the number of downloads, so the popularity, the social signal aggregated over the whole platform, you get very different results. Like unpredictability of the final rankings is very different. So you can imagine that there is an underlying, let's say, song quality that may be appraised by looking at users independently. And when they have this social influence, all the rankings on the several experiments are modified in a very random way, in a way. So just the display of this information changes the things. You have to come back on online social networks, another study, 2014, that tried to compare the influence of displaying the social signal of people recommending some piece of information, some newspaper article, by trying several conditions. Displaying the origin of the information, displaying the number of people that recommend it, or displaying both. And so not even changing anything about the underlying computation, is just displaying social signals. And in a nutshell, the results show that basically when you show the social endorsement, I mean, normally there is a preference, let's say an organic preference for people who are rather declaring themselves as blue to choose content from, let's say, blue sources, and the other way around. Whenever the signals are displayed, actually differences between these preferences flattens out. That is, in fact, the social signal trumps whatever is related to the semantic signal. So again, here, just the display and the arrangement of information also is likely to bias information consumption. So that second step is quite essential. I mean, trying to understand things in terms of shifts with respect to an organic baseline, and also try to disentangle the upstream processing and the downstream display. I want to use this kind of framework to study 3 different levels where algorithmic recommendation is of interest, of academic interest. And the first one, and it also corresponds to 3 cases. The first one is very upstream. It's about the principles that are being used to develop recommendation algorithms. There is a lot of discussion about the fact that coders may introduce some principles in the algorithms just by coding, unknowingly, for instance, influencing, introducing political decisions that are essentially political eventually. And so there's a significant part of the qualitative literature on the coding, on the creation of algorithms that calls for opening the black box of algorithms, trying to understand how they are made. So this is precisely what we've done in a study that is to be published, and trying to understand how the code writing is being guided by principles. So basically, this is a qualitative study in a sense. We interviewed, and actually it was a study made with Jérémy Poirot, a PhD student here, who did the interviews. 30 interviews with 30 coders from 30 different companies, semi-directed interviews, but the way they develop algorithms, about the way they use users, the way they test, and the way they understand reflexively their decisions as well. And so the main results, there are 2 categories of results. The first, understanding the development modes, how they proceed, what kind of principles they use. And so, for instance, they all, or most of them, refer to existing algorithmic practices. So there is a sort of tension between a constant reference to the main actors of the domain who are, in their view, doing something generally too simple, too blunt. So they are usually referring to Amazon, Facebook, and so on as actors who are doing recommendation in a very basic way. And at the same time, because they are working in a R&D context where innovation and originality is important, what is interesting is to notice that most developers recon that they actually use simple and ubiquitous methods there is a sort of toolbox of the field, especially collaborative filtering, from which they tap to actually design those algorithms. So there is a common pool of techniques that are used by roughly everyone here. The second thing is the way they are incrementally developing the algorithms. And here, well, that it is incremental is not surprising in itself. It's a mix of sequential development, so progressive refinement of the algorithms, the recommendation algorithms, and also parallel development, in the sense that the development loop, the development cycle, is based on trying several solutions, many solutions sometimes at the same time, with a winner-take-all process. So the core element here is the notion of A/B testing. That, in fact, for a given algorithm, they develop a lot of different versions, improved versions, and they test on users these versions to see which one performs best. And so tests are actually the core progress driver here, as if even in the discourse of developers, they had their own agency. Tests are framed as the final arbitrators. When they have to make a design choice, is basically the decisional process is outsourced to tests. It's like, we don't necessarily know why this version of the algorithm works better, but since it works best on users according to an optimization principle, then this is the version we retain. And then we go on. So basically what that means is that there is a sort of hybrid, everything works as there is a hybrid man-machine evolutionary algorithm where developers are in charge of introducing mutations, the test on users, the best one is selected, and so on and so forth. And the algorithm progresses from that point. This is also connected to some normative concerns. Like once we have this loop, it's interesting to see what governs this loop. And there's what we call grand ideals that comes very often also in the discourse of the developers. There is a broad discourse, not surprising either, on serendipity, the necessity of not confining users inside of bubbles. Again, unlike the other platforms who supposedly do that. So the goal is we want to develop recommendation algorithms that insist on serendipity, bring novelty to users. And there is also a broad discourse on the necessity to read the mind of users. They say, for instance, ideally, the ideal algorithm would be in the brain of the users and guide them towards what they wanted without knowing it. And we are here to help. That's the goal of the algorithm. So these are the grand ideals. And what's funny is that it's in practice connected with what we call, or not connected actually, with what we call small ideals. That is that basically this evolutionary loop that I described before is based on optimizing metrics and simple ones, clicks, revenue, time spent on the platform, you name it. The developers are at the same time aware that the problems they are solving are largely optimization problems and optimization of this. So everything works as if when you open the black box of this development cycle, when there are grand ideals on one side, small ideals on the other side, the two things are non-connected. The wires are not there between them. And what actually works for the development and the evolution of the algorithm is the optimization metrics. So in a way, we could even claim that once you are given two variables for a given platform, the grammar of the platform, that is what is possible on the platform, listening to songs, clicking on like, creating a user profile, I mean, the whole grammar of the platform, once you have given this, and you also have given the set of optimization metrics, most often just one optimization metrics, then the development of the recommendation algorithm follows naturally, let's say, evolutionarily from these two givens. It's a matter of months, it's a matter of years to find the optimal algorithm or to refine optimal algorithms that do optimize those metrics. But basically, the connection between the political principles or possible political principles that are claimed by developers or even startup managers is not really there once the simple optimization metrics has been given. So we contend it changes a little bit the way of framing the question of the regulation of algorithms or the politics of algorithms, just as a result of shifting the focus from developers to basically simply the optimization metrics that have been chosen. Notwithstanding, this still poses the question of the existence of filter bubbles. I mean, these algorithms are in place, and what is the shift? And so the state of the art, from the intuition, the well-known intuition of Pariser now that there could be filter bubbles that based on the behavior of users reinforce their preferences, the empirical state of the art seems to converge on the observation that it's not very bubbly, actually. There's a lot of studies on very different platforms with very different empirical protocols, so it's very hard to compare. But many studies, be it on YouTube, using movie lens data on Facebook, as I mentioned, on Tumblr for recommending users, Spotify for recommending music, Google News recommending news items, seems to say that actually comparing the consumption under the influence of algorithms versus not expands or tends to not restrict the landscape accessible to users. There are some notable exceptions. Quite obviously, in the case of explicit preferences, that is when users choose to subscribe to some sources. For instance, on Twitter, you subscribe to some users, you are actually asking the platform to feed you with stuff that you selected in the first place. So in this case, the platform works as a very trivial recommender and feeds you with your preferences. So here we observe bubbliness. And there are also other cases where an increasing number of cases, actually, where the literature seems to conclude that actually, yes, in these situations, algorithms tend to restrict a little bit the horizon of the users. There's a recent paper 2020 on Spotify, and there's also a recent paper in 2020 on YouTube that I'm just going to present here. So there seems to be a little bit of debate here. Let me first focus on this paper. And so go to the level of in situ recommendation, and namely on YouTube, where everyone knows the platform. There is essentially a video. There is also a bar on the side made of recommended videos. And those recommended videos are actually a mix of recommended for you videos, which are personalized recommendations, and non-recommended for you videos, which are what we call mean field recommendations. That means this connects with the assumption that on the side of YouTube, each video is connected to recommended videos independently of the user. And so that makes it also easier to study, but it provides a reference of the landscape of recommendations that YouTube is imposing, overlaying on the possibly personalized recommendations. So in this study, we wanted to study this, this landscape, the shape of this landscape, and whether there were variations and whether there are signs of confinement. We started with seeds, a certain number of seeds from various topics. I'm not going to enter into the details, but basically a seed is a video. And the question is simply, assuming a user random walks from this video, what kind of landscape are they likely to access? And is this landscape going to be confined, or is this landscape, this network landscape, going to bring that user to different areas? So this is connected to understanding what recommendations, mean field recommendations there are at the level of a video, and also to make sure that this network may be defined. And so YouTube, for instance, very practically in terms of data collection, returns for every request a different set of videos. I mean, this mean field evolves for each request. So the first point was to check whether this seed-centered landscape had some stability. It does, because even though there is variations, variability, there are also many videos that show up consistently. And in fact, what happens is that what we call the plateau of video that were recurrently recommended is of a quite constant size. That means for each video, there is a number of around 20 videos, 19, 20, 21 videos that are systematically, let's say, more than half of the time recommended. So to simplify, we decided to schematize this and to say, essentially, there is a network where we take those top videos, those plateau videos, and that creates our recommendation network. It's a very peculiar network for those of you who are familiar with complex networks, because the degree connectivity is relatively constant. Each node is connected to around 20 other nodes. So it's a peculiar network, but still we can observe their structure. And so, for instance, in this illustration, which is essentially visual, we have three sample graphs. The one on the left here is quite compact. It's actually compact because there is a lot of redundancy in the links, and so it's a quite clustered structure. So the connectivity is essentially isotropic as well. And the other one is a little bit more, let's say, fragmented, and the last one exhibits subclusters into which a user may be quote unquote trapped more than in the isotropic case. What we measure here, technically, but in a quite simple way, is the diversity of the random walk. That is, if a user starts from a seed and travels, what is the diversity of the set of recommended videos that they will have access to? And so essentially this entropy, we connected it with the size of the graph. That is the whole portfolio of videos that were accessed. And so in a counterintuitive way, we observed that when the random walk is diverse, that means makes it possible to access videos in a quite diverse way, giving a chance to each video of the subgraph. It corresponds also to situations where the graph is smaller. It means in this case, it's as if you are traveling through the graph in a more uniform way, but it's a smaller one. And what is more is that these smaller graphs are also the most redundant semantically. It means in these smaller graphs, even though you seem to access more randomly, more uniformly the videos that are part of this graph, they are also very similar. We tested this with a human evaluation, where the three regions, the region 1 is the one where we have the small graphs with the large entropies, so diversity, diverse but small. Region 3 is non-diverse but large. And so according to humans, those smaller graphs are also made of recommendations that are extremely similar to one another. So in a way, a signature of confinement. Interestingly, those videos in the region 1 also are the ones that gather the highest number of views, and by far. So that means when there is this semantic homogeneity in an apparent isotropic navigation landscape, but still it's extremely similar and semantically redundant. We could also establish some findings on the topical confinement, where starting from a certain category, YouTube labeled category, we would essentially end up in the same category. The same for the quartiles of the numbers of views. It's on the top and the bottom right. Basically, if you start with a video that is not being viewed so much, has a small number of views, then the transition likelihood is rather biased towards other videos that are not very much viewed either. So there are small islands in a way, in terms of topics, in terms of numbers of views, and also in terms of what we call the contentment index, which is basically the ratio between the number of likes and the number of dislikes. So there is also a tendency for the negative contentment videos to transition towards positive contentment videos. So you still don't stay too much, at least in an area where contentment is negative. And the last step here to describe this confinement is to look at the novelty. I mean, as I said, each request yields a different portfolio of recommendations, but this portfolio evolves through time, of course. It's not the same even 2 weeks after. And so we collected the data for 2 weeks continuously. On the left, the graph shows the percentage of videos that have the percentage of novelty, that is of new things at the immediate level of the recommendations. That is for what is the novelty for a seed, for the recommendations assigned to a seed that are novel with respect to 2 weeks before. So there are variations, but on the whole, half of the recommendations, the stable one, the plateau ones, are new. But still, if we look at where they come from, and that's the middle graph, in fact, they often come from the rest of the graph that could be explored at depth 2, that is just one step further, or at depth 3, that is another step further. So what that means is that those induced recommendation graphs, the novelty that happens at the first layer, immediately close to the seed, is actually coming from the second layer. So something that could have been accessed by just one more hop, or at the third level. So the novelty is not so novel. And this renewal of the recommendations is actually happening within for the majority of the case, above 60% on average from the local surrounding of the video. So in this case, even though we didn't use personalized data, we seem to conclude that indeed there is confinement on YouTube, that it's non-uniform either. I mean, there are some areas of confinement, stronger areas than others, but this goes in the way of the bubbly conclusion. And so this brings me to the third level of study, where we reintroduced users and usages, and where I like to introduce this notion of filter niche instead of filter bubble. This study was based on Deezer data, so the music streaming platform. We have the whole listening histories of users anonymized, it's a non-social setting in the sense that users are not connected to friends, so there is no influence, let's say, of a social network. So it's individuals still, they are facing the platform. And so the question is how their tastes and how their consumption evolves with respect to the various recommendation devices that there are. And in fact, here, we also distinguish something that increases on music streaming platforms at least, and others, news items platforms as well, which is the editorial recommendation. So recommendation can be algorithmic, but it can also be platform-wide, partly human, in the sense that there are editors who are hired by the platform and who compose some sets of recommendations. For instance, they create a playlist that would be music from the 80s, and so on and so forth. So you have the three types of recommendation, the two types of recommendation, sorry, and the organic use as well for each user. And question is, again, the question could be to what extent recommendation changes the behavior of users, blah, blah, blah. But if we think of the state of the art with this kind of possible debate between, okay, some results show it's bubbly, others seem to say it's not. So even on the same platform, we get those mixed results. Could there be another explanation, an underlying variable? And so this is where we introduce this notion of filter niche, much more even than on YouTube, by considering different types of users. Basically, the assumption is that different types of users just react differently to a recommendation, or even they have a use of recommendation that differs and thus different expectations. This is also something that is quite ubiquitous in the qualitative literature on the use of algorithms. I mean, it's been documented that, yeah, different users have different literacy levels with respect to algorithms, and they also use it or use them and use recommendation in general for different purposes. So starting with this assumption, we looked at the profile of users and wanted to distinguish different classes. On Deezer, as on other music streaming platforms, you have so those three types of access that we gather as editorial, based on editorial recommendation, algorithmic, or organic. And each user has a proportion of use of each of the affordances. So it's a point in ternary space. The sum of proportions is 100%. And so each dot is a user here, corresponding to a certain level of use of the different affordances. We studied for 1 year, 9,000 users, around 9,000 users, and we use a simple k-means algorithm to distinguish those classes. So the point is not to find clusters, but rather to define bins of different usage levels. And so we have O+ users, they are the very organic ones, O users, the organic ones, E, the ones that rely more on editorial, and A, algorithmic. On the whole, P here is the number of plays. We have roughly the same distributions. It means on the whole, between these different classes of users, there are heavy users, non-heavy users. It's kind of the same or similar distributions in terms of the use of the platform. So it's not discriminative, but their use of the affordances and their portfolio is. And so we distinguish, in this case, that's the goal here, the influence of recommendation with respect to those users. So we introduce two dimensions, two very simple dimensions of diversity. The first one is dispersion. It's the ratio between the number of unique songs and the number of plays, S over P. So if a user listens repeatedly only to the same song, it goes to 0. If the user listens to each song once, it goes to 1. And we distinguish, for instance, this redundancy in a way with respect to user types, A, E, O plus. And so we see that in general, on these small plots, these histograms are ranked. I mean, the x-axis is the S over P. So more to the left means less dispersion, so more redundancy. And more to the right means less dispersion, more uniqueness, more dispersion, sorry. And so what we see is that dispersion is generally lower as a function of activity in the mode. That is, for algorithmic users, to put it simply, the algorithmic access is the less dispersed and the more redundant. For editorial access, it's the editorial mode that has this. And for the O plus access, it's the organic mode of access. So that means depending on just these different user types, we have different diversity just at the level of the portfolio of songs. The second dimension of diversity is semantic, not structural like the previous one. It's the notion of nicheness or artist popularity. And so basically we distinguish 4 bins of artist popularities based on the data. So there are very popular artists, less popular artists, low popular artists, new 1, new 2, new 3, new 4. And so we see, for instance, that there is already an aggregate, the difference between the different access modes, that algorithmic access tends to be used for more niche artists. Editorial, it's more mainstream. And organic access, it's more a U-curve. And also dispersion increases with niche content. That means for the content that is more niche, the least mainstream, there is more dispersion, more uniqueness of the play. And so basically using this semantic diversity notion, we can look at the different user types in terms of what kind of mainstream, non-mainstream music they are listening to with respect to a baseline, which would be the uniformly random access to artists of a certain popularity. So let's say if it goes on this curve here, if it goes over 0, that means this type of user is listening more to this kind of mainstreamness bin. For instance, algorithmic, you see it's a U-curve on the left. That means there is a preference for the middle mainstream artists, and they avoid, with respect to the rest, all other things being equal, the mainstream, and to some extent, they are equal, uniform on the least mainstream, the more niche content. For editorial users, we see that it's decreasing, it's monotonous. I mean, editorial users have a preference for mainstream stuff. For the organic users, the O users, it's the opposite, kind of. And O plus, it's a U-curve again, but reverted. And based on this, what matters here, in terms of framing this question of recommendation influence, is to look at the effect of the different access modes for each user. So you have those small plots. Start to be complicated, but I'll summarize afterwards. Each type of curve corresponds to a type of access: algorithmic, editorial, organic. And each column, again, corresponds to a different type of users. And what we see here is that, for instance, the algorithmic access tends to pull users towards niche, except for the E users. For the E users, the algorithmic recommendation actually does not do that. The editorial access is monotonous, and the organic access, again, it depends on the users. So the appetence, let's say, or the bias linked to a certain mode of access depends on the users. And to summarize, in fact, we have to think of the original ternary plot. You have these 4 types of users. Usually, any paper that aims at appraising the effect of recommendation is basically providing, would be the take-home message, one of these small subplots. That is, okay, given a certain measure of diversity, it's the x-axis, then some mode of access recommendation is actually inducing more diversity in this regard, or less diversity, and so on and so forth. And so what matters here in this picture is to say, okay, well, actually, maybe to also comprehend the mixed results and sometimes contradictory results, if we introduce a partition, a typology of users, personas that are related to to different expectations towards recommendation, whatever it is, then we have a diversity of these plots that are all in the same picture. And that also possibly reconcile some of the conflicting results. But for some users, recommendation is actually a filter bubble. For others, it's not, it's the opposite. It's a way to access more diverse, to explore newer horizons. And so basically these are Filterniche, all these small plots, whereby there could be filter bubbles or non-filter bubbles within them. I see the time is short, so I will not give the take-home messages of this study, but essentially what I want to finish with is that there is no blanket answer to the impact of recommendation, also algorithmic. There are diverse answers that depend on content, users, affordances, use conditions, but not so much on coders once, let's say, corporate has fixed the optimization metrics. And we get obviously more clear-cut answers if we distinguish beforehand persona, user types, and affordance use. Thanks a lot.
Thank you very much, Camille, for the fascinating overview and the mix of methods, very impressive. So if you want to ask any question to Camille, as I was indicated in the chat, please don't hesitate to use a Q&A interface. It was a lot of information, so you can take your time to elaborate your question. I have one question just to kickstart the conversation, Camille, and I cannot not ask you. You using in the paper on Deezer, the last study you presented, two ways to measure the diversity of music consumption. One is the redundancy, so you're always listening to the same track, and the second one has to do with how popular the artists are. So am I only listening to Beyonce, or am I trying to listen to artists who are less popular than that? And so, of course, the question is whether it's really that kind of diversity that people think when questioning whether recommendation algorithm really creates bubbles. What I mean is that you may consider that someone who's only listening to country music, but a very unusual artist in country music, and many of them is not someone who has a very diverse type of music consumption. So what do you do with that, this semantic dimension of diversity?
Yeah, that's a very good question. Actually, it's related also to the labeling of the data. I mean, in this case, we have the labels, and we thought about considering them. I mean, we have the genres essentially, and they have a quite usual long-tailed distribution. There's a lot of pop, rock, and a lot of hip hop. We could use those labels. We could also use embedding spaces. In another paper, we also used embedding spaces to look at the distance between songs and essentially, I mean, the geometric extent of the consumption in that space. So that's an orthogonal dimension in a way, because if you consider a genre, the semantic feature that we used here, the popularity or non-popularity, it's almost a fractal issue, because there are going to be within the genre popular, least popular artists. So this is a totally valid dimension as well for semantic things. And we decided, well, then I will become to be even more technical here. We decided against using them, the genres, essentially because of the labeling safety. I mean, it's not safe labels, and it's a lot of overlapping partitions. I mean, the songs can belong, and artists can belong to several genres. It's a lot of deconstruction there. The other option, the embedding space, on paper sounds a little bit more promising, but also it depends a lot on what you are using for the embedding. So in the end, you could end up with the classical music being closer to pop than pop to rock, just because of the way of the popularity of the genres on the platform. So this is a very tricky question to find the proper geometric space that has this kind of underlying notion of closeness, you know, of, for instance, as you said, staying in the folk music area. Within that, what does that mean? Does it mean you stay in the genre in the terms of labels, or does it mean you stay in the same geometric area? We thought it was a little bit difficult to end up with something clear here, and this is why we thought, okay, mainstreamness is also a good measure in a sense. I mean, it's very practical. We could have added a third dimension here and refined the findings for sure. I think we were also satisfied with the idea that, okay, even looking at these simple dimensions, we could already exhibit different behaviors, basically, or different, I mean, filter bubbles and filter non-bubbles.
Thank you very much. Actually, just I mean, Myrtle River is asking a question. I also wanted to ask you. I don't know whether you can read it right now, but I'm going to just say it alone. Very interesting talk. I'm interested in hearing more about the interviews with coders. For instance, what were the structured interviews like? Were the coders diverse in sense of educational or personal background, gender, nationality, etc.? And I just like to add one question to this question, which is, I suppose that one of the coder was coming from Deezer, so I'd be interested in knowing also whether you know about the Deezer algorithm, the Deezer recommendation algorithm. Meaning, is it based on some embedding space itself? Connecting songs the one with the other, but please, I'll let you choose which question you want to answer first.
I'll proceed in order. Regarding the interviews, it's a good question. I'll start with the end, like the diversity of coders. In terms of nationality, there was a lot of French. It was a lot of France-based startups, and so a lot of French people. The educational background was very much in engineering. The gender was very, I mean, it was overwhelmingly male, even though it was overwhelmingly male in terms of the people contacted, and it was even more overwhelmingly male in terms of the people who accepted to do the interview. So that provides a sort of field where there is a lot of homogeneity, and in terms of age as well, around 30 years old. In terms of the functions, it depends also on the size of the company. So in small startups, you had a sort of mix between, you know, being a founder, being a developer. In larger ones, you had different departments. And so the interviews, to sketch it roughly, were divided into several sections. How is the work organized within the company? How is your work organized? Where do you find inspiration for, I mean, how do you come up with new ideas for the development of the algorithms? What is the process of selecting them? What is the process of making them evolve? And so leaving a lot of freedom here to answer and to explain the day-to-day functioning of the work. And also with respect to the, let's say, technical infrastructure, and especially that led the engineers, the developers, to speak a lot about the A/B tests. That was also quite widespread. We were actually surprised of this sort of autopiloting mode, because we weren't, I mean, obviously, honestly, we were not expecting, we were expecting to find, you know, some principles that the developers would say, oh, we want to introduce this, and this is why we coded that this way. We were expecting to see the visible hand behind the invisible hand of recommendation. And actually we, I mean, my impression is we found a pretty much invisible hand of the evolutionary optimization. With respect to Deezer, to come to your question, Jean-Philippe, I'm trying to think if I'm disclosing anything sensitive, but I assume not. Because of the partnership in the other projects. So irrespective of the interviews, because there were just one or maybe two interviews with Deezer coders, because of the partnership in the other A&R grant, we gathered some information. So we know, I think Spotify, I mean, I think it's mainstream in the industry, so it's why I don't feel I disclose anything. There are embeddings of different kinds that are being used to base the recommendation on in a sort of sometimes magical way, not necessarily knowing, I mean, using it as a feature and letting the machine learning optimization do something out of it. Embeddings could be of the very low-level audio type, embedding space in terms of, let's say active music or slow contemplative, I mean. And there are embeddings that, I mean, you can think of embeddings that are related to co-usage, co-listening, so this kind of things, networks. And there are things that are also related to, you could have noticed that if you use these applications related to the redundancy and also to providing you, as opposed, I would say, to the classical recommendation issue, recommend you stuff that you already know of. And by learning that actually users, in the case of music consumption, love to listen to the same song several times. So there is this notion of redundancy, of good recommendation that brings you to where you were. That is also part of the thing. We didn't study specifically the difference of profiles in terms of really skipping, for instance, plays when you have a recommendation. I mean, this comes into too much detail. This is on the table. But at this time, we haven't looked at this. But I trust Deezer engineers or this music streaming platform engineers know well to what extent they add this redundancy in the recipe.
So back to the main result, you were, I mean, not the main result, but your observation that most coders in the startups, they claim they want to build the algorithm that is going to free people from bubbles, because all the other recommendation algorithm, of course, are going to trap people within those bubbles. It means that I'm still unclear about that. Does it mean that they have this in mind, but the micro level optimization and scores that they try to optimize are only at the level of clicks, revenues, and there's something I didn't quite got in between the great principle you drew during the interviews and the way this A/B testing is working, because it seems to me that it was purely based on the time they spent on watching a video or listening to music. So there's no what I understand is that when you interviewed them, they do not try to optimize any measure of diversity as such.
Not the ones we, at least not the ones we interviewed. That's exactly this. I mean, there are academic works and there is a discussion in the industry on the use of, I mean, even departing from precision recall, these kind of things, about introducing other features, diversity based, and perhaps also trying to optimize this as a, but from the interviews, it wasn't, I mean, it didn't show up really in the description of the everyday work. I mean, when they started to say, okay, what is the principle against which you are A/B testing? It was essentially those very simple business metrics. And interestingly, regarding the other questions, so as you said, what is the goal of the algorithm? What are you trying to do? Then you had an open answer, a more qualitative one, which is, yeah, we're trying to, our dream would be a world free of redundancy, in a way, to paraphrase the World Bank motto. But that dream does not translate into everyday practice in the general case.
But if you connect the interview with the last use case, which is based on observational data, it means that even when you optimize on quite simple objectives like people want to keep on listening, you end up with a system which is kind of fostering diversity still.
This is true, and this is also just, I mean, my take would be that this is just a result of the machine learning process capturing the appetency of users for diversity. That is, it's just by chance, by coincidence. We say we optimize revenue, and it happens that users when they're presented with diverse programming, for instance, they tend to like it and they tend to subscribe. Okay. Ergo, there is a post hoc connection, actual connection between the algorithm and fostering diversity, but just by chance. And there are also other voices, for instance, on YouTube that tend to say that the chance in this case leads to the opposite, that the chance evolution of optimizing time spent on the platform actually leads to results, behaviors, data configurations that seem to foster confinement in some cases. So
thank you all for being here. Thank you so much again to the speaker, the host, and everybody who asked questions. And we look forward to seeing you again sometime soon. Thanks and bye-bye.